Okay, we've got a full program inside here this morning, and so let me just jump in. So I'm going to be talking about forage plant growth, and I'll go into a bit of detail, but my main goal is for you to understand when we tell you the detriments to overgrazing, the benefits to rotational or improved grazing. I'm going to tell you exactly what's kind of happening in the plants and why we talk about that and what the benefit of that is. So when we're trying to understand plant growth, there's the physiology, the vital processes happening inside the plant. Morphology is what the form and the structure of the plant, kind of what we look at the plant as the morphology, these plants up here, what's happening inside is the physiology. And we'll talk about how both of those relate to grazing management. So what is needed for this pasture to regrow? Okay, what does it need to be able to regrow? Throw out some things. Water, sunlight, needs nutrients. Okay, and all of those things go into giving the plant energy for regrowing. But the energy comes from, sunlight, but the plant can't make any energy, can't make any carbohydrates without having some leaves. The leaves are the solar collectors, absorbing the sunlight, and then those processes are happening inside the leaves. So, think about all these solar farms, or if you have some solar panels for your electric fence charger or on your roof, and you go and you paint over those, or you get a bunch of birds to land on that solar fence charger and they cover it up and it can't absorb any sunlight. If you don't have any leaves, your pastures can't absorb sunlight and they're not going to grow, they're not going to store energy. So I don't want to say the more leaves the better. I guess that's true, but eventually the plants get so big that they're not enough quality and they're not worth using. But maintaining active leaf growth and sufficient quantity of it makes a huge difference, or all the difference, in that plant being able to take up sunlight and produce energy. So leaf area remaining, stored carbohydrates in the base of the plant and in the roots for it to grow back after grazing, particularly after winter when there's not leaves there. So all of this happens through this really neat process of photosynthesis. So you've got light energy from the sun being converted. You've got carbon dioxide in the air, water coming up through the ground, those being combined to make sugar, make simple carbohydrates, and then oxygen's given off. So we get all kind of benefits through this process. We have oxygen to breathe. We've got the carbohydrates in the plant to consume. The animals have those to consume. So just an amazing process. There's two pathways. You may hear about C3 and C4 plants, but we'll refer to them mainly just as the C3 are the cool season plants, the C4 are the warm season, meaning they're going to grow better at warmer temperatures. In this area of the U.S. and north, our predominant plants are cool season plants because the predominant temperatures throughout the year are more on that temperatures in the 60s, 70s, low 80s.
Try this one once. I don't know if that's
Okay, does that sound any better? Okay. As Chris said, I'll try to use my big boy voice today. We'll come back to this, and Chris talked about the different species yesterday. There's also in plants a process of respiration. Now, we know respiration because that's how we survive. We breathe in oxygen. That oxygen in our lungs gets into our blood, travels throughout the body, is able to allow us to utilize those nutrients that we've consumed. If you think about it, you're a little bit weak and you drink some Gatorade that has a high sugar content, the sugar plus oxygen with the mitochondria in the plant or in the cells of every living organism produces carbon dioxide, water, and energy. Plants need this process too. The sun's not shining all the time. So this is the way that they're surviving overnight. This is the way that they continue to grow overnight. It's by burning off some of those sugars that were developed during the daytime. So respiration is needed for maintenance and growth. Maintenance is higher as the temperature increases. So when we get into the summer months and the temperature is warmer overnight, particularly in our cool season grasses, they're burning off a fair bit of the sugars they've produced during the day just to survive. That's part of why the growth slows down in the summer. Cool season grasses just aren't as efficient at those warmer temperatures. Warm season grasses are. A lot of factors affect respiration. And in fact, photosynthesis, a lot of things affect it. But one key point is that, or a lot of key points, but cool season species, their peak growth is at about half of full sunlight. So on a cloudy day, they're getting enough sunlight. They're still growing fine, which can be a good thing. Warm season species peak at full sunlight. People have often commented to me, I've got a warm season plant, maybe it's sorghum sudan, maybe it's even growing corn, and it just doesn't seem to grow very fast during, I've got a week of cloudy weather, and then I get a few sunny days and it seems like it's growing inches a day, and that's probably true because the peak growth, the peak photosynthesis is happening at full sunlight. Carbon dioxide, I'm not going to go here so much into details, but my main point is that C4 plants are more efficient at how the carbon dioxide from the air is fixed in the plant into carbohydrates. So cool season species there, on average, peak growth is about 70 degrees. Warm season, it's about 90 degrees. So you think about planting crabgrass or planting another warm season annual like sorghum sudan, or you have Bermuda grass. It's going to grow faster and faster as long as it has enough water into the 90s. Cool season species, once they get past the 70s into the 80s, their growth is slowing down. A lot of factors affect photosynthesis. That's the thing I'm not going to go through and list this because I want to get onto some of the more practical things, but you can look through this on your own. One of the real keys to having proper fertilizer, proper nutrition, whether it's through just good recycling of manure and urine or whether you're needing to add something, is nitrogen's a key part of the chlorophyll, which is absorbing the sunlight for photosynthesis of enzymes. Potassium is important for a number of things in the plant, but it's essential for the stomates, the openings on the leaves that take in the carbon dioxide. So if you don't have the proper nutrition for the plant, then you really start screwing up the processes. So for one exception to when I talked about cool season, warm season grasses is the plant alfalfa. It is a cool season plant, but it can have very good growth from the 60s through the low 90s if it has sufficient water. So there are some exceptions to this rule. That's one advantage to alfalfa, good growth in the spring, summer, and fall. It is a little more tricky as far as grazing management. Here we're talking in a grazing school, but as I mentioned yesterday, it can be grazed as long as it's given a rest period, and we'll come back to that a little bit later. Okay, now getting into a little bit more practical things. Okay, just 4 different grasses here that are common in Kentucky and surrounding states. And I want to refer to each of these from the standpoint of their structure, where their leaves are oriented. So you look at Kentucky bluegrass, and if we put a dotted line here, it represents close grazing, 2-inch grazing. Kentucky bluegrass still can maintain some leaves below a close grazing or even a close mowing. So it's still able to continue photosynthesis. You see the leaf area of the Kentucky bluegrass even here close to the bottom here, the soil level. it can continue photosynthesis even under close grazing. Orchard grass, on the other hand, very productive grass, but very upright growth. In close grazing, it doesn't maintain leaves under close grazing. So you're cutting off those solar collectors with close grazing of orchard grass. So leaving that 3 to 4 inches or even more makes a huge difference in the ability of orchard grass to continue to grow. Tall fescue is somewhere in between those two. So it can maintain fairly photosynthesis under fairly close grazing, but still has a little bit more upright growth. And Bermuda grass, the warm season perennial, it has a lot of advantages in that it can have productive growth because it's a warm season. It can maintain leaves close to the ground. It's also spreading by underground rhizomes and above ground stolons. Another key point is that grasses, look at the size of the root system on grasses. They're fibrous. It's not a big thick root like you have with a taprooted plant like a red clover or alfalfa. So grasses, they're not storing their carbohydrates in the root system. They're storing the carbohydrates in the base of the stem. So another advantage to really close grazing is you're taking off this base, this thick area where carbohydrates are being stored. So part of the advantage to leaving more stubble going into the winter and for the spring is the plant can have carbohydrates in the base to grow back. Part of the reason we talked about yesterday with frost seeding that you graze close so the clover seed will hit the ground, so the grass is actually weakened and isn't as competitive. But for most of us, we're thinking about maintaining the base, maintaining some leaves for the plants to be able to grow back, for the grasses to be able to grow back. Okay, here's just an example of putting all this together. A little schematic put together by Gary Bates at University of Tennessee. Phase 1 of growth, plants are just tiny. There's low leaf area, not a lot of light being intercepted, so there's reduced photosynthesis. There's not as much solar collectors there. New growth comes from energy stored in the roots or in the crown of the plant. Slow regrowth after grazing in that really short stage. Then you've got a rapid growth phase. A lot of leaves, that would be something like the plants here that have been clipped and they're growing back. The orchard grass here, the fescue. So high leaf area, a lot of light being intercepted. The leaves are still young and they're very efficient. High photosynthetic rate, fast growth rate. So our real goal is keep plants in this fast growth rate. Don't graze them too close. Don't let them grow too tall, because in that third phase, there's a lot of leaves. Plants that are this big and even bigger, and they have seed heads. High leaf area, so a lot of light can be intercepted, but the leaves are older. They're not as efficient. The photosynthesis isn't happening as quickly. There's also seed heads or blooms, so that's taking up energy to try to produce the seed or the bloom. Lower photosynthetic rate, slower regrowth rate. On our Forage website, down at the bottom, there's a decision aids, and this is another thing that you can click on these buttons, something developed by Ozzie Abai at Virginia Tech, and just look more details of how plants grow back. I won't go through that today. Okay, here's an example of what I'm talking about. And this is at the research station that Dr. Teutsch was at Blackstone in Southwest Virginia. So what we have here is a tall fescue variety test that was planted in the fall, established fairly well, as you can see from the solid rows. The following spring and summer were very dry. But here where we were cutting the varieties, I don't need to use my pointer, it doesn't work on this screen, but we had the different varieties of tall fescue, and we were cutting those about once a month. We left a 3 to 4 inch stubble. Okay, so this is fairly soon after one of the cuttings. The superintendent at the station, he was being nice to us, and he wanted to keep things looking really nice and closely mowed around that variety test. Now, we didn't really mean for him to do this, but he cut it close with the lawnmower, less than 2-inch cutting height. But he gives a really good example. Because where he had cut close on a regular basis, those plants, partly because of the drought, partly they hadn't gotten fully established, but they were struggling. We weren't maintaining leaf area. And so they hadn't filled in like where we had left this greater leaf area. So even in a drought in the summer with a cool season grass, given that period of time, that extra leaf area for regrowth made a huge difference in how that stand established and how it was maintained. Another problem when you have a lot of bare open ground, you've got sunlight hitting the ground, more water evaporating, more heating of the soil that's going to cause those cool season plants to grow even slower. So all of this goes into not just thinking about top growth, but thinking about root growth. Close grazing depletes carbohydrates needed for top growth, but also for root growth. So you'll get, this is representing continuous grazing or frequent grazing. You've got some regrowth, but not much of it. Look at this plant, and you don't have much top growth, but you don't have much root growth. You've got less drought tolerance, less nutrient uptake, all kind of issues. Now, a rule of thumb is that a plant every year is recycling about 30% of its root system. So some of the roots are dying off, particularly in the summer when it's hot and in the winter when it's not growing. And that's fine, but if you've got a plant that's never able to regenerate the root system that's lost or that's sloughed off over time, then you get shorter and shorter root systems. Where this is rotational grazing, this is no grazing. We don't want no grazing, but we want to maintain the root system, maintain the top growth. So here's an example of what you're going to end up with. If you're grazing close, graze it repeatedly. You've got, here's good grazing on a low-growing grass like Kentucky bluegrass or Bermuda grass. Here's where we're grazing too hard. So you have a pruned back root system. You get a few weeds that start to grow, particularly tap-rooted weeds. They get the root systems down below the root system of grass, and they've got all the water and nutrients they need. No wonder they're a problem. And this particular one, you can say, oh, I've got to spray a herbicide. And sure, that'll kill the weeds, but if you don't solve the underlying problem, then the weeds are just going to come back. So you want good top growth to cover the ground, but you want a good root system to be competitive. Or a native warm season grass like this, maintaining the root system and maintaining top growth. Just one quick comment on this. Our normal grass growth during most of the year is like what we've got at the top. So you've got the grass growing. When it's grazed off or when it's mowed off, the grass leaves just continue to elongate. So this was cut here. You notice that the tips of the leaves are flat, are cut off, because the leaves are elongating from the base. So they're just continuing to stretch out. Here's orchard grass that's never been cut this spring, so you see the tips of the leaves. That's just how the plant grows. When you've got a plant that's producing a seed head, particularly a cool season grass, and it's cut off, then the growing point for the plant is up here where the seed head is. The plant has to come, the new shoots have to come back from the base. So you've got a slower regrowth. Now, a lot of our cool season grasses, they're not, every one of the shoots of the plant or the tillers doesn't produce a seed head, so you still have some leafy growth at the base, but we still have a delay when plants get to a seed head stage and they're cut off or they're grazed off. Chris, let's play the video if it'll work. On the YouTube channel, the KY Forage's YouTube channel, we've got a whole bunch of recordings, but we've got about 7 different time-lapse videos. And we're going to just show one to you. You stay at Verbo if you want to as well. That's the price. That's why you have the YouTube channel for free. Okay, watch what's happening here. Comparing a plant on the left representing continuous grazing, one on the right representing rotational grazing. And look at the regrowth over a 5-day period. So this is orchard grass. By its growth structure, it's even more vulnerable to close grazing than some of those other grasses. Okay, what are you noticing? If this was your pasture, would you rather have the one on the right, the one on the left? Okay, good. You are awake, or most of you answered correctly. I did have a lady one time at one of our grazing schools that, well, I think it was just at a regular meeting, and she raised her hand and she said, the one on the left, I think that's good. I've got these fat ponies that they're gaining weight, all the time, so I really need not much grass. So if you have any overweight cattle or sheep or goats, then the one on the left. You graze hard, it's not going to grow very much. So what the difference? Yeah.
I was curious. You say continuous grazing, like down to 1 inch. What if you just did it for overseeding and did it maybe once or twice? Is it still going to have that same effect?
Doesn't have nearly that effect. And so that close grazing for overseeding makes sense. You want to kind of slow things down a little bit. So one close grazing, plants recover from that, and there's useful purposes in that. Or sometimes you leave animals out for too long, or you have to leave them in one area. Don't get obsessed over this. But let me mention that the example here of these two plants actually was just all we did. The two plants were growing. They looked about like this, and then we came in at the beginning of the month. We clipped the one on the left to 1 inch, and then every week for the rest of that month, we clipped it to 1 inch. So just 4 clippings. The one on the right, we clipped to 3.5 inches at the beginning of the month. The end of the month, we clipped it again to 3.5 inches, and you're looking at the growth happening. So one time wouldn't have really mattered, but just those 4 times over the period of a month made a difference. And I won't show you with this presentation, but we did the same thing on orchard grass in a hayfield where we cut it close 4 times during the year versus 2 or 4 inches. If you compare the cutting close down to 1 inch to the 4 inches, we had a 20% stand in that hayfield where we had cut it close 4 times. No, Chris, don't worry about that one, Jeff. So we don't have the videos embedded. We shut the same thing when I've got a video on the YouTube channel between orchard grass and tall fescue. And the point here is that with proper rest, even a plant that can be vulnerable to overgrazing can be very competitive. These two were simulated rotational grazing, and if you go to the YouTube and look at it, the orchard grass is actually growing back faster than the tall fescue. Now, I'm not meaning that it's going to choke out the tall fescue, but often, like we were hearing about yesterday at the farm, they're seeing some orchard grass come back into their fields because they're using that rotational grazing. So you're giving it at least some advantage or opportunity. Okay, with legumes are different, particularly the taprooted legumes, like alfalfa or red clover. So they've got a taproot which gives an advantage in their ability to take up water and nutrients from deeper depths. It's also they're storing carbohydrates in those taproots for regrowth. So they can be cut closer or grazed closer, and they'll grow back from the carbohydrates in the taproot, but you've got to give a long rest period to build back those carbohydrates. White clover is a little bit in between. It doesn't have that big of a taproot or root system, so it still needs some leaf area to continue to grow. So with alfalfa, with red clover, with the lespedizas, you have a big drop in the carbohydrates in the roots after cutting or grazing. You need to give time to build those up. So giving a rest period with red clover, 3 or more weeks, with alfalfa, 4 or more weeks to build back is important. And I'm going to flip through this pretty quick because I've got another example to show you. So here is grazing rotationally with alfalfa or red clover. You've got a big drop to start with because the plant's using the taproot carbohydrates. It builds back up. You cut it or graze it again, the same thing goes. You have this cycle happening over time. Frequent grazing, you've just overseeded red clover, you're glad to have it, but you're anxious to use it. You're anxious for that ability to dilute the effects of fescue. But repeated grazings or continuous grazing or too frequent of grazings, you never build back the carbohydrates and the plants eventually weaken and die. Okay, so here's an example kind of putting together some of the stuff that we've talked about. Your goal in most of our pastures is to have legumes and to have grasses, both of those. So a taprooted legume, it can dominate at a low cutting or grazing height because it's going to grow back from the carbohydrates in the taproot. So low cutting height or grazing height favors plants more dependent on root carbohydrates as long as there's a good rest period. High grazing or cutting height can favor the grasses. And this just shows 3 inches. We'd probably be more talking about, on a practical standpoint, leaving 4 or 5 inches if you want the grasses to have some competitive advantage. High cutting height or grazing height favors plants more dependent on leaf area for regrowth. So if they've got more leaves, once they're cut or grazed, the leaves just extend. So that starts happening right away. Whereas those legumes are going to take a little bit longer to grow back. Not longer to grow back. They're going to grow back from the carbohydrates in the root system. If the grass is cut close, it's going to come back slower. The legumes will come back faster. So in your pocket guide toward the end, we've got a same table here, starting and stopping grazing. I think we even have the rotational grazing publication in the book. But in short, each species, the height to start grazing, the height to stop grazing varies. So orchard grass, we say 8 to 12 is a good height to start grazing. It's okay for it to be a little bit larger, but that's that active growth stage. Leave it 3 to 6 inches for it to be able to come back quickly. You get into a warm season annual like pearl millet or sorghum sudan grass, you want it to be a couple of feet tall before you start. But you need to leave 8 to 12 inches for it to be able to grow back fast. The same with native warm season grasses like switchgrass or big blue stem. So with our goal with pasture management is to maximize regrowth, we all know that, is to have good persistence, good survival, and is to have good quality. We're going to be able to do those through managed grazing, through maintaining that leaf area with the grasses, through giving rest periods. So the grazing stick, it had the marks at the bottom that were showing you when you were getting below 3 inches. Now you can obviously just measure that. You can, a little rule of thumb, when your cattle are grazing, they got their head down. If you're seeing their nose, you're probably grazing too close. When it's about eyeball level, then that's a good time to probably just start grazing. Someone in one of our grazing schools was a bit of a smart aleck, and he said, well, my cattle, when they first walk into the pasture, they don't have their head down. And I said, well, if you can see their hoofs, then it's too close. If you can see their knees here. So you know what I'm talking about. Okay, here's a, say, 50-acre small farm. In fact, maybe let's think about it. Yesterday at Kate and Justin's, they talked about 50 acres is what they had. If you bought a farm and that's what it was, and it had no internal fences, how many fences would you need to construct for you to be able to start rotational grazing? Somebody, I think, one? All you really need is one to get started. Now, a lot of us think, well, I've got to do this fancy system and all these fences all over the place, but it's too much trouble. Or this is a rented farm. I can't afford to do any fencing. But if you put one fence through the middle, you've got the water source, whether it's a pond or a tank or whatever, that they can get to. So now that's not going to work if you're grazing, if your pasture is orchard grass alfalfa, because it needs those rest periods. But if it's tall fescue and bluegrass and white clover, if you give 2 weeks of grazing and 2 weeks of rest, those can tolerate that more frequent grazing. And that's going to be better than just that continuous grazing because you're moving the animals back and forth. Now, if you can go to 4 subdivisions or 8 subdivisions, every subdivision gives a benefit. Research many years ago at Virginia Tech by Roy Blazer is he found that going from one big pasture and starting to subdivide it, that the first 3 subdivisions, taking 1 to 3, gave the greatest benefits. Now, after you go to 4, 5, 6, you still were getting benefits. But if you could go to 3, in this system, to be able to have 2 weeks on with these lower growing grasses, 2 weeks on, 4 weeks off, to have that ability gives you a lot of options. So even on that rented farm that you only know that you have for 1 year, just one fence with a solar charger through the middle, going over the water source can make a huge difference. So a guide with grasses is to leave some leaves. Provide regrowth energy, even if it looks like you're being wasteful. And you're moving into a drought period, say, and all of your neighbors are grazing close because they want to get use of that forage, and they see you with this extra regrowth, and they say, what are you doing? You're being wasteful. But you're thinking to yourself, I've got a good root system. I'm maintaining the leaf area. I'm keeping the soil surface shaded so I'm not losing as much water. I'm not heating up the soil. Even though, quote, I'm not utilizing everything I have right now, I'm going to have a lot more later on. I'm going to have more growth into that drought period. When the drought period finishes, my grasses are going to come back faster. We mentioned some yesterday, an advantage of hay feeding in the late summer, early fall, to be able to grow some grass through the fall or for that grass to be able to recover faster. So good rule of thumb, graze to favor the legume. It's usually harder keeping legumes in pasture than it is grasses, so we like to favor the legume. So grazing low favors the legume. I don't mean to the ground. I just mean if you want to give a benefit to the legume, graze lower, giving a good rest period. Graze high favors the grass. The regrowth interval becomes very important for that carbohydrate cycling. So different forages. Continuous grazing, tall fescue, bluegrass, white clover, Bermuda grass can handle that. It's not best for it, but it can survive. Moderate grazing, orchard grass, red clover, given just a 3-week rest period, not going too close, it'll tolerate that. You've got to have fairly defined and longer rest periods when you get into grazing alfalfa or native warm season grasses. So we're talking, a 4-week rest at a minimum, and not taking it down to the ground as with the native warm season grasses. Alfalfa can be taken close as long as it has that rest period. Questions on this? Yeah.
When you cut the grass, does that kill some of the roots?
I'm thinking of a research study, and I won't quote it exactly right, but you do, when you cut close, it does stop root growth for a period of time. Chris, I think it was a USDA study done back in the 50s, and when they only removed half of the growth and still had a lot of leaf area, roots continued to grow. When they took it all the way down, the roots stopped, but they picked back up after a little over a week. But where they had repeated cutting close, the root systems are just being pruned back. So you've probably heard of the adage, a good rule of grazing is to take half, leave half. That's going to allow that continued root growth. That's going to allow that quick regrowth. Now that's just, that's pretty easy in the spring. You use some quick grazing rotations. You don't take it down too close. It's going to grow back faster. As you get into the summer, that's kind of a harder thing to do. And the grass is growing back slower, so you may be taking a bit more. And all of these things are rules of thumb, and then you figure out what's going to work in your situation. Yeah. Yes.
You were talking about, one big continuous pasture, and if you can just cut it in half.
Mm-hmm.
I've got one that's been grazed like 50 or whatever, probably forever.
Okay.
It's got hills. If I can get one fence in there,
Yes.
Did you say 2 weeks back and forth? Is that?
I mean, that would be a rule of thumb, because you like to give as long a rest period as you can. But the longer the rest period, if you only have two, the shorter the, the longer the rest period, the longer the period that you're grazing. So, the spring of the year, yeah, that 2 weeks on, 2 weeks off would make a difference. And, you get a feel as you look at it, and as we look at our grazing when we're out there this afternoon, if there's still good growth, you may say, I'm going to go 3 weeks and let that other one recover a little bit more. Yeah. Yes.
If you have a field that's like 80% clover,
Yeah.
and you've got other paddocks that are almost 100% fescue, is there a risk of bloat by going into almost pure clover?
Yes. Yeah. And I think we have our bloat publication in the book. What section is that under, Jeff? Are you going to talk about that later?
I think it's under section 12.
Okay, section 12, there's a really good publication when you've got a lot of clover or you're grazing a high proportion legume. But there's several good rules of thumb. A simple thing is before you turn them into that really high clover, is fill them up, have some dry hay there. Fill them up with some dry hay. Have some dry hay available so they're going to keep that roughage in there. Not turning them in there first thing in the morning when the dew's still on it. So a few simple rules of thumb. And Jeff, any other comment you want to make when you've got that, you've mainly been grazing grass, and then you've got this high proportion clover paddock?
Yeah, it's actually in section 10, sorry. But strip grazing works better too. If you can strip graze like that, because you force them to eat the more stemmy part of the plant as well, and not just selectively pull those highly digestible leaves off.
White clover, it doesn't really have stems. It has stem-like structures, but it's mainly just leafy. So they're getting a whole lot of leaves anytime they're grazing white clover. Red clover or alfalfa, if you let it grow up, and these aren't great examples because they're not too tall, but you've got more stems in proportion to leaves. And so red clover is less prone to bloat, not because the leaves are less prone, but because you let it grow up to a late bud stage, a few blooms out there, they're going to get a lot of stems while they're getting the leaves. Particularly, as Jeff said, where you're strip grazing, you're forcing not just getting mouthfuls of leaves, they've got to eat it all the way down. Now, I don't want to minimize bloat because that's a huge concern and obviously can kill animals, but I've often heard the quote, the fear of bloat causes more losses than actual bloat. Now, if you have a bloat storm on your farm and you lose several animals, then obviously that quote doesn't mean much to you. Any other questions? Yes, sir.
The bloat blocks, the proxylene, have you had any experience?
So
with that?
proloxylene will prevent bloat if they get sufficient quantity per day. So bloat blocks is a way to give it, but you can't guarantee how much they're going to get from the bloat block. But from a practical standpoint, that's probably the easiest thing, Jeff, is the bloat block. The types you can put into the water, then you can more regulate how much they get.
It's not clear for the U.S. It's in Canada. We don't have feed labels for the liquid in the U.S.
Okay. So you're going to have to put proloxylene, mix it in the mineral, or a bloat block, or if you're feeding some supplemental feed, you can mix it in there.
You can buy the powder. I like the powder because if you buy the powder, it's expensive, but you can mix it in grain, you can mix it in your mineral. The blocks, if they're not accustomed to the blocks, they don't always readily come to the blocks, and most farmers aren't going to want to spend $25 for a block, and you need one block for about every 8 to 10 head. And so then they're looking at dropping maybe $100 in blocks if they've got a decent sized herd, and they just don't want to do that.
So if you were using blocks, Jeff, you don't want to have the blocks out there before they get into the clover, get them used to actually eating it.
Can you mix the powder with water?
No, legally we cannot say you can do that.
But it will mix with it?
No, it will not. It's not it won't, it's a surfactant or detergent. It doesn't, the coating on it really doesn't resolve.
But if you've got that 80% clover and you're really worried about it, then if you mix it with some grain and you're just giving them, a pound a day, just whatever quantity so that they're consuming the mineral, then you know how much they're going to be eating. Yeah.
Yeah, if you can commit to moving cattle 1 time per day is the best time of day based on plant sugars or cow habit, like 7 in the morning or 3 in the afternoon.
So you have from the morning to the afternoon, the soluble sugars in the plant increase 3 to 4% during the day. So you do have a higher soluble energy, you know, you might say Gatorade, quick boost to those animals if you turn them into a new paddock in the afternoon versus in the morning. It's a bit lower. And with horse people that are worried about problems with their pre-diabetic horses, turning them out in the morning is a little safer than in the afternoon. Yeah.
If you have lush orchard grass and alfalfa mix, and it's 16 to 20 inches tall, you want to minimize that paddock so they graze down that plant down that day and get them out of there like in 1 day.
1 day or 2 or 3 days, but that's kind of what Jeff was saying, is having a strip or a smaller area so they're forced to graze it, then that's going to greatly reduce the chance of bloat if you've got a mixture.
How many hours do they need to be in there per day to get what their requirements? Because if you leave them in there, they're going to trample that right down.
Jeff, you'll probably talk about that a little bit.